Good evening, my dear. I am Rakesh Shove from Sunbeam Sun City. Jai Hind you all. My dear, today I am uploading the miscellaneous problems on the uses of dimensions. Miscellaneous means mixed problems, right? All mixed problem. Dimension uses 1 also, dimension uses 2 also, and dimension uses 3 also you will find in this numericals. And this is the last video on the dimensions numericals. From tomorrow onward, I will start uploading the numericals on the parallax method, that is to measure a distance, and about accuracy, errors and precision. Accuracy, errors and precisions from tomorrow onward. So now, my dear, today's lectures are very important. I will upload whatever number of numericals I am uploading, just find it out. So it is a miscellaneous problem from my side, mixed problem on 3 uses of dimension. The first is to check the equations correctness. Second is to convert one system into another system, and third one to develop or to establish relationship among different physical quantity. My aim is to take at least 2 to 3 numericals. Am I clear? At least the last use, which has been to develop the relation, should be get done very well. Okay. Now the first question which I have taken up is, you can see on the board, right? The question is the rate of flow of liquid. And my dear, the concept is here rate of flow. This word is a lot of concept. The rate of flow denoted by capital V of a liquid flowing through a pipe of radius R, pipe having a radius R, and pressure gradient. You all in my dimension earlier all videos, I told you any quantity when ended up with gradient, that quantity will divide by distance. And therefore pressure gradient is denoted by P divided by distance, that is P divided by length. Is given by Poiseuille equation. My dear, we read this as Poiseuille's equation. Poiseuille's. Okay, this is a name of scientists. Poise and Poiseuille's are the units also. So Poiseuille's equation. So this equation which I have written on the board is famous by the name Poiseuille's equation. Okay, so don't get afraid of this kind of words there in the exams. And that Poiseuille's equation is given by capital V. And what is capital V? That is rate of flow of liquid is capital V is pi divided by 8. Pi is a number, 8 is also a number. Multiply by P into R power 4 divided by eta into L. You can see here P by L, P and L. That is P by L is a pressure gradient, R is the radius, and eta is a coefficient of viscosity. P by L. You can see P upon L, that is pressure gradient, sir. And R is the radius, eta is a coefficient of viscosity. What is the question? Check the dimensional consistency of the equation. Please, you focus that how will you come to know that which use I am supposed to use. Because out of 3 uses, which I supposed to do? Because it looks like the third use. Because I told there is a word problem in the third use. No, my dear. If you remember, I told you there is a word depend. In the third use, that while developing the relationship among different physical quantity, there is a word depend. जब तक वो depend word आपको दिखाई नहीं दे रहा है, please don't go on that third use. And second use ultimately sir नहीं है, because it is not one system into another system. कोई system दिखाई नहीं दे रहा है. So of course it is a first use, and there also we have given you one hint that you have to do this with the checking the dimensional consistency of the equation, that is left hand side and right hand side type question. So let's start with I mean to say it is on first use, my dear. So I am disclosing right now. Now this is based on the first use of dimension. So let's start on the principle of homogeneity. So let's start here, my dear. Question is, here I am writing, given V is equal to pi divided by 8. This is P R power 4 divided by eta multiplied by L. That is given. Now, my dear, my suggestion is there is a word rate of flow. Because don't you think this is volume. Please don't you think it is volume. Clearly mentioned, I am writing here, since V is the rate of flow of liquid. This is concept, my dear. Here I am writing concept. So please try to understand what is the beautiful concept of this question. So here it is, sir, V is not volume. Your language, अगर volume होता तो इधर लिखता volume of liquid. Please don't assume yourself it is volume. We have given the word rate of flow. So what is rate of flow? I'll tell you what is actually meaning of this. This is nothing but volume of liquid. Rate of flow of liquid is nothing but volume of liquid flowing per, this is divided by time. Because you all know that whenever there is a word rate, that thing should divide by time, my dear. So here the rate of flow of liquid, when we said, sir, it is volume of liquid flowing per second. Per second. Actually, this is the meaning of this line. So what is rate of flow of liquid? So rate of flow of liquid is volume of liquid flowing per second. So if it is a volume of liquid flowing per second, so what is the dimension for this V which is given? The dimension for this V is volume divided by time. And that is nothing but, my dear, volume dimension is L power 3 and dimension of T is T power 1. So the dimension of the quantity which is given, that is rate of flow of liquid, will be given by L power 3 M power 0 T power minus 1. This is the first and important concept. Rest all you know. Rest all you know. So my dear, here please take care, the V is the rate of flow of liquid which is given in the question. Is actually, it is not volume, simply volume, sir. No doubt it is denoted by capital V, but it is not volume because of the word rate. It is a volume of liquid flowing divided by time. Please, this is one thing. And sir, volume of liquid divided by time, that doesn't make a much difficulty now. I will substitute volume with divide by time. Dimension of volume, dimension of time will give me the dimension of rate of flow of liquid. Okay. So my dear, I think now left hand side dimension is very clear to you all. So I will write here left hand side. So what is on left hand side? That is capital V. What is capital V? Sir, it is volume. I am writing here again. The same thing I am writing here. Volume of liquid flowing divided by time. This is actually your this rate of flow. And therefore, my dear, this will become V is equal to volume L power 3 T power 1. This is the dimension. So here the entire dimension of left hand side will be L power 3 M power 0 T power minus 1. I will put this as equation number 1. That is left hand side. Sorry, put your question as 1. जो क्वेश्चन दिया है, put that as equation 1 and put this as equation 2. I hope the first concept is clear. मैं बार बार बोल रहा हूँ, capital V is not only volume चौबे sir, it is rate of flow, and rate of flow is actually volume divided by time, not only volume, because sir there is a rate and volume word कहीं नहीं दिया, but it is but natural. When we say flow of liquid, तो कितना volume of liquid flow किया, that is important. So, but the word rate is given, so that volume of liquid jitna flow kiya hai should get divided by time, and that is a word. So here is a word play game, my dear. Take care of that. Am I clear? चलिए abbreviation देख के काम नहीं करो कि अरे सर ये तो capital V है तो volume है तो all and all. Sir, it is rate of flow, ये volume upon time है. Okay, this is one thing. So जो बार बार conceptual है वही मैं बोलते रहूँगा. Now on the right hand side, my dear, on the right hand side we have pi by 8 P r power 4 divided by eta into L. Now my dear, when I will go for the dimension of the right hand side, here I will write dimension of P, dimension of r power 4 divided by dimension of eta multiplied by dimension of L. Sir, what about pi by 8? Since pi by 8 is a number, it is dimensionless. So nice. So I have written everything, but out of that I have removed pi by 8. And I am interested in dimension of pressure r power 4 eta and L. Pi by 8 bar. Okay. Now what is the dimension of this quantity, my dear? So dimension of pressure, everybody remember L minus 1, M1, T minus 2. How? Here I am doing the rough work. There is a rough work. Rough work. This was the concept. This is the pi by 8 is a dimensionless. Now rough work. Sir, एक एक के dimension लिखते हैं. Pressure dimension. Sir, pressure dimension is force upon area. So force is nothing but L1, M1, T minus 2 divided by area L2. So dimension of pressure will be L minus 1, M1, T minus 2. I am doing again and again. अब तक तो यार you please learn कर लो. What is the dimension of pressure? Dimension of pressure is L1, L minus 1, M1, T minus 2. I hope it is clear. So now here I got the dimension for pressure. I have shown you that pressure is L minus 1, M1, T minus 2. Now my dear, let's go to the next dimension, that is dimension of R power 4. So no need of doing in the rough work, everybody know what is R power 4? L power 4, right? Here divided by, now here divided by eta, oh, dimension of eta, that I required in rough work, eta dimension. You all know eta is given by F. What is eta dimension, my dear? You all know, if you remember the formula of eta, the formula of eta was F is equal to eta A, that is dV, or here I can write into velocity gradient. See, I am doing again and again, so that you can get the things together in the rough work. So eta is equal to F upon A into velocity gradient. Okay. So eta dimension is F upon A into velocity gradient. I am doing each and every step. Now what is F? F dimension is L1, M1, T minus 2. What is the dimension of area? Sir, L power 2. And dimension of velocity gradient? That is velocity upon length. Velocity gradient, pressure gradient क्या है? Pressure upon length. This is velocity upon length. Velocity dimension is L power 1. M power 0, T power minus 1 upon length. Length is L power 1. So L power 1 numerator and L power 1 denominator. Cancel. So what will be the dimension? L0, M0, T power minus 1. I will write here. Wait. I will write here. So dimension of eta is F upon area into velocity gradient. Okay? Now, what is the dimension of F? Dimension of F is L1, M1, T minus 2. Okay? Force ka dimension is over. Area dimension L power 2. And velocity gradient is velocity upon time. Velocity upon length. राइट वेलोसिटी का डायमेंशन रिकॉल करो L1 M0 T minus 1 वापस से L1 M0 T minus 1 वेलोसिटी हो गया डिवाइड बाय लेंथ बिकॉज ग्रेडियंट इज हियर सो डिवाइड बाय L power 1 so it will be my dear L power 1 divided by L power 1 will be L power 0 that is L power 0 M power 0 T power minus 1 so it is. So I got the answer as L power 0, M power 0, T power minus 1 for velocity gradient. So now what is the dimension for eta beta? Calculate here. This is L power 1 and this is L power 2 and this is L power 0. Denominator it is L power 2 only. So it is final answer will be 1 and this 2 L power minus 1. This is M power 1 and here it is M power 0. M power 1 will be as it is. And T power minus 2 and this minus 1 will go up. Minus 1 will go up, become plus 1 and answer is minus 1. Now my dear, if in the exam, if you remember this dimension of eta, if you remember the dimension of eta that it is L power minus 1, M power 1 and T power minus 1, then you are supposed to substitute directly here eta ka dimension. No need to do in the rough work. But if you are not confident, please, so भले 2 मिनट जाएगा to find the dimension चलेगा but do right way otherwise entire your effort will go waste. It is not of use. So if you remember dimension I will suggest write directly but if you don't remember the dimension do this way in the rough work get confirm and then substitute. So here eta is L power minus 1 m power 1 t power minus 1 into the dimension of L, that is L power 1. So now what is the dimension I am getting for the right hand side? Dimension for the right hand side, my dear, you can see this is L power minus 1 and L power 4. Here it is L power 4. Become, first I will write numerator L power 3 m power 1 t power minus 2. In denominator what I am getting, beta? In denominator what I am getting? In denominator it is L power minus 1 and L power 1 will be L power 0, m power 1 t power minus 1. So now what is the entire dimension, beta? This is L power 3 and this is L power 0. So answer will be L power 3. Superb. So the answer here is L power 3. Here it is m power 1 and m power 1. So answer will be m power 0. And here answer is t power minus 2 and this minus 1 go up, become plus 1. Minus 2 plus 1. Answer is minus 1. I hope it is clear. So here I have done, this is a rough work. So this I got on the right hand side. So right hand side pi by 8 p r power 4 divided by eta into L. The dimension of that I got it as L power 3 m power 0 t power minus 1 here. So now this I will put it as equation number 2. Sorry, not 2, it is already 2 is here. Equation number 3. So I hope you understood the equation 2 and equation 3 very well. So what is the final answer, beta, on the right hand side? The final answer on the right hand side is L power 3 m power 0 t power minus 1. What is the final answer of the left hand side? L power 3 m power 0 t power minus 1. So my dear, if I substitute equation 2 and 3, now I will rub this rough work. So I hope you understood this concept. Okay, so I am rubbing this concept. I am rubbing here. I am rubbing the rough work. And that is the last step, bache, to substitute both the equations 2 and 3 in one. Okay. So the concept is only, my dear, only one concept in the question, and the concept is, sir, the terminology, that is rate of flow of liquid. Because rate of flow of liquid का दूसरा नाम है volume of liquid divided by time. It is not only volume. Bas, that is the concept. Rest all you can do easily if you know all the dimension. So this is our equation number 3. Here I will say substituting 2 and 3 in 1. So my dear, 2 is V ka value here and 3 is right hand side value. Therefore, this is, my dear, what is the equation? V is equal to pi by 8. This is nothing but P r power 4 divided by eta multiplied by L. Now for V, the dimension is L power 3 m power 0 t power minus 1. And on the right hand side for this quantity, the dimension is L power 3 m power 0 t power minus 1. And therefore I can say left hand side dimension is equal to, my dear, right hand side dimension, and hence I will say the last word, the given equation is consistent with dimension. Am I clear? This is all at end. You can end here also, no issue. But at the end, if you write one line from the question, then it is wonderful from question itself. And what is that line? Thus, the given equation is consistent, or the given equation is dimensionally correct. Either you write the statement from the question only, or you write your own statement. The given equation is dimensionally correct at the end. So I hope you understood this first example on the first uses of dimension, that is on principle of homogeneity. Now let's go to the next question of it. Well, my dear, look at the next sum. The next sum is the value of capital G. You all know capital G. Capital G is gravitational constant. You all know, right? Otherwise, you should take care that the capital G is gravitational constant. Here I am writing. So the value of capital G, that is gravitational constant in CGS system. It is given CGS system, is 6.67 into 10 power minus 8 dyne centimeter square gram power minus 2. Right? Dyne centimeter square gram power minus 2. Calculate the value in SI unit. My dear, so simple and basic question. Here they have not given any other thing. Let me tell you, the question can be difficult if they have given some other hints also. I will show you in my next video of the same kind question but with a different way. So my dear, here the question is very simple, that they ask only to convert this unit dyne centimeter square and gram power minus 2 in SI. So then that time this value will be what? Simple question. I hope it is clear. Right now it is given in CGS. The value of G is given in CGS. We want the value of G in SI, that is MKS. When I say SI unit, that is MKS. So now my dear, how to tackle this question? How to tackle this question is very important for this to tackle this question. So now when we go for calculating it, simple. There's nothing to be tension about it. Now my dear, this stage you all know that here I will write here given G is equal to, there are various methods. So I will go for some complex or difficult method if there is a simple way of solving this. Because you, as a question side, they have not said ki you do this, you do that. Because at this stage you know how much dyne is how much Newton. See, you know, SI में dyne for SI it is Newton. Centimeter square it is meter. And gram become kilogram. So if you know this all, then why you will take hurdle and you will go for conversion and all and all. So what is the simple method is, look at it, a very simple method you can do this way in your exam. There is many numerical now you can solve if the question is like this. Simple two-line question, simple question is this. So don't get in more complications. This is my request. Because books has a different way of solving N1, N2, this, that. But my dear, if the question is simply asked that why convert this G ka value in SI, how much it will be in SI, so don't take much confusion. If you know at this stage, is that dyne can be Newton, centimeter become meter and gram become kilogram. And that what value they carry. Okay. So now here given G is equal to 6.67 into 10 to the power minus 8 dyne centimeter square gram power minus 2. And my dear, believe me, we all today, even teachers, we all are doing in the same manner today also. We don't take N1, N2 and all and all. Unless and until there is some other information they have said, they have shared in the question. But here they have simply asked by convert this value in SI. Okay, that is MKS. Now my dear, here we have to say, put this as equation number 1. The given question as a equation number 1. Now you write here, since we know that, just this information we know that, one dyne is equal to 10 to the power minus 5 Newton. I have done this and everybody have done the basic. 1 joule is 10 power 7 arc. 1 Newton is 10 power 5 dyne. So 1 dyne is 10 power minus 5 Newton. So here I am writing that also, since. How I can come to know that? Because 1 Newton is 10 power 5 dyne. Therefore 1 dyne, why, on what basis I have written this? Because 1 Newton is 10 power 5 dyne. Therefore 1 dyne is 10 power minus 5 Newton. Substitute this as the equation number 2. Similarly my dear, also 1 centimeter is 10 power minus 2 meter. How I came to know about this? Since 1 meter is 10 power 2 centimeter. है ना? Because मेरे को जो चाहिए, as you all know, मैंने अपने topics में बोला है, here the CGS will be converted into SI. The CGS system is converted into SI. So I will convert all CGS units in SI. And by this method. So sir, 1 meter is 10 power 2 centimeter. So 1 centimeter will be what? 1 centimeter will become 10 power minus 2 meter. But here it is not 1 centimeter. Here it is 1 centimeter square. So square will become 10 power minus 2. Here also it is square. because here I have put square, so here also square and here also square. So now this become 1 centimeter square is equal to 10 power minus 4 square meter. Equation number 3. So nice. Similarly, my dear, also you know that 1 gram, last one, 1 gram is 10 power minus 3 kilogram. How? Sir, since 1 kilogram is 10 power 3 gram. So 1 gram is 10 power minus 3 kilogram. Therefore, here it is gram power minus 2. Therefore, 1 gram power minus 2 will become 10 power minus 3. How much I multiplied here? Minus 2. So here also I will multiply minus 2 and kilogram will also become minus 2. है ना? पहले 1 ग्राम था. 1 gram is 10 power minus 3 kilogram. कैसे? Because 1 kilogram is 10 power 3 gram. है ना? 1 kilogram is 10 power 3 gram. So 1 gram is 10 power minus 3 kilogram. इतना तो सबको मालूम है. Sir, but we are not interested in 1 gram. We are interested in 1 gram power minus 2. So here I put minus 2 over the gram के ऊपर, gram के power में I put minus 2 here. So I have to put minus 2 at every place on the right hand side also. So it is 10 power minus 3 into minus 2 power में into kilogram also with power minus 2. I hope minus 2, minus 2, minus 2. I multiply to each power, left hand side and right hand side. So now it become बच्चों 1 gram power minus 2 is equal to 10 power minus 3 into minus 2 will be plus 6. 3 2s are 6 and minus become plus kilogram power minus 2. This is my equation number 4. Now my dear, I think the sum is solved. So here you can see what I have taken the steps. You can see the steps carefully, an important equation. The first equation was nothing but, sir, the first equation, that is the second equation, say we have start converting. Sir, 1 dyne is 10 power minus 5 Newton. Sir, 1 centimeter square is 10 power minus 4 square meter. And sir, 1 gram power minus 2 is nothing but 10 power 6 kilogram power minus 2. So now I will order substituting 2, 3 and 4 in 1. Therefore, the value of, नहीं मैं पहले लिखता हूँ. Therefore, the value of G, the value of capital G in SI unit is obtained by. कैसे मिला मुझे value of G in SI? SI में मुझे कैसे मिलेगा सर ये G का value? Sir, it will be obtained by substituting 2, 3, 4 in 1. In 1. Therefore, my dear, this is G is equal to, beautiful line I have written, please make a note of it. The value of G, yes, that's a question, in SI's unit is obtained. How it will be obtained? By substituting this in equation 1. So G is equal to 6.67 into 10 to the power minus 8 as it is. And in place of dyne, now in place of dyne, my dear, I will write in place of dyne, what should I write? Sir, dyne is there, so I will write into 10 to the power minus 5, dyne become Newton. Now next, centimeter square, that is into 10 power minus 4 square meter. In place of centimeter square, I have written 10 power minus 4 square meter into gram power minus 2, that is 10 power 6 kilogram power minus 2. Here you can see. So nice. Therefore, G is equal to 6.67 into 10 to the power minus 8 into minus 5 minus 4. Right? So I will write everything together. 10 power minus 5 into 10 power minus 4 into 10 power 6. And I will write unit now. Newton. Here it is meter square and here it is kilogram power minus 2. Newton, meter square, kilogram power minus 2 and their powers I have written here. Now therefore G is equal to 6.67 into 10 power minus 8 and minus 5. Minus 13 and minus 4. Minus 17 plus 6. 10 power minus 11 Newton meter square kg power minus 2. सो डाइन का बेटा न्यूटन हो गया, सेंटीमीटर स्क्वायर का मीटर स्क्वायर हो गया, ग्राम पावर -2 का किलोग्राम पावर -2 हो गया. आई होप यू ऑल अंडरस्टूड द क्वेश्चन. Such a nice and such a simple way to solve such questions. Please don't leave such questions, and these are the method. I just take up the units. Dyne ka Newton, how much one dyne is how much Newton, how much 1 centimeter square is how much meter square, and how much 1 gram power -2 is how much kilogram power -2. And then I substituted, that's all. I hope you understood the question. Let's go to the next question. Now my dear, let's go to the third question, because if you can see, first question was on first use, second I have put on second use, and yeah, you see also that second use so nicely we can do, right? So don't take a tension if I'll show you some more questions on second system. But my dear, unless and until the question is changing by themselves, then you have to use your brain. Otherwise, if it is asked simply convert in SI from CGS, then you just substitute the CGS into SI and get the value. Okay, I'll show you one critical question in that cases. One critical question, and if you can ask me, if you can see in other book some more questions, I am most welcome. Now, the period of vibration, here the third question is given. The period of vibration. My dear, here the word period of vibration, they have not said time period of vibration. See the logic of all this way of asking the question. I have done many questions on this, but I used to say time period of vibration, and we used to substitute capital T. But here they have missing time word. So no issues. Even period means as a time, and it is denoted by capital T. I have left the denotation so that I can explain you while discussing. So the period of vibration, that is capital T, of tuning fork. Now my dear, you all are aware that the tuning fork is look like this. Sure beta, just recall this figure in the laboratory, physics laboratory. This is a tuning fork, and this shape, this is called, my dear, prongs, and this is called as stem, and this entire figure is a figure of tuning fork. And now my dear, in tuning fork, as soon as I banged it, जैसे मैंने इसको रबर पैड पे या किसी चीज पे I banged, except some solid material, it should be a flexible material on which I will bank this tuning fork like this. And as soon as I bang, this prong will start vibrating. The prongs will start vibrating. ठीक है बेटा? And that's what they say, कि the vibration of these prongs, who vibrate in tuning fork? Prong vibrates. And their vibration, the time period of this prong vibration depend upon length. Let I have take the length as small l, length of its prong. ये वाइब्रेशन कितना करेगा prong का टाइम पीरियड का जो वाइब्रेशन है, is it depend upon length? The question is depend. You can understand which use I supposed to here make the use of that. Depend word is there. So take care of this depend, and the first is length of the prong, length of the prong. Second, density. Here my dear, density denotation is being changed from my side. So if it is changed, you will take that abbreviation which is given by the question side. Now you will not take rho. Please, if I have given density D, then you have to take D, and you have to solve it D only. Don't in between put it as rho. You cannot change our symbol which is given in the question paper. You have no right. Okay? Though you have a mind that sir, density was so denoted by rho, you have given D. That's our choice, our way of asking question. You should not pinpoint about it that what denotation we have given. But if we have given in question paper D, you will continue with D. You will not put rho. Okay, that is one thing. And Young's moduli of elasticity, remember this, denoted by capital Y. I have done this. Many of the students observing this video, most of the videos are going, that is wonderful from your side, my dear. Young's modulus. Sir, Young's modulus has the same elasticity as the elasticity constant. because it is one of the elasticity constant. So it will have the same dimension as the dimension of elasticity constant, that is stress upon strain. I will discuss all that. Am I clear? And derive an expression for period of vibration, that is capital T, period of vibration, by the method of dimensions. This is the question, and you all understood by looking my numerical, my dear. I have given the word depend, and if I have given the word depend, you understood that which uses we are supposed to use here for the dimension. Now let's begin. Let's begin with the topic that how to do this. How to do this. Let's start. Here, my dear, the first word is time period T. So I am here, I am starting. T depend. Now I don't know whether it depend directly or it depend inversely. I have given in my one of the question also. Last video is on this topic only. It depend on length. It depend on density. And it depend on Young's modulus. Itna clear. But sir, we don't know whether this time period depend on length directly or inversely. If it is inversely, the power will be negative. If it is directly, the power will be positive. But that power right now I don't know. So I put the power as say A. Here I put the power as B. And here I put the power as C. I hope this much is clear. And here, my dear, I will put equation number 1. Now next equation, this is T is equal to K, that is proportionality sign is removed by K. This is L power A, D power B, Y power C. And Y is Young's modulus, D is density, L is length. Equation number 2. Now my dear, as quick I will do the rough work. You all remember rough work. So here is the rough work. The very first dimension is the dimension of time period. I hope it is clear, right? So dimension of time period is nothing but L0, M0, T power 1. That's time period is over. Now next is left hand side T is over. Now next is length. Dimension for length. So dimension for length will be L power 1, M power 0, T power 0. That is over. Dimension of density. So what is density? Mass upon volume. So this is mass will be M only, volume will be L power 3. So what is dimension? L power minus 3, M power 1, T power 0. Density is over. And the last is Young's modulus. Dimension of Young's modulus is nothing but, sir, dimension of stress upon dimension of strain. So nice. Sir, strain don't have dimension. Strain is dimensionless. So it is L power 0, M power 0, T power 0. It is dimensionless. And stress has a dimension of force upon area. That is dimension of pressure. So if I solve this, I will get L power minus 1. Because you can see F ka dimension is L power 1, M power 1, T power minus 2. आराम से F का dimension is L power 1, M power 1, T power minus 2. Denominator में area है, that is L power 2. So L power 2 will go up, become L power minus 1, M power 1, T power minus 2. I hope it is clear, my dear. So now what will be happen here? So we all know that in denominator, sir, it is strain, it is L power 0, M power 0, T power 0. So I got the dimension of Young's modulus. What is the dimension of Young's modulus? Same as the dimension of stress. And that is L power minus 1, M power 1, T power minus 2. That is exactly the dimension of pressure. This I have done so many times. Please don't forget now. So now here, sir, I hope all dimensions is found. Time period, length, density and Young's modulus. That's what I require. So now substitute this all. The dimension of T here, L0, M0, T power 1 is equal to K. Now be fast. L power 1, M power 0, T power 0, whole power A. That is dimension of length. Dimension of density you can see from here. I told you all, don't do it at the last page of the answer sheet. Do it in front of the question so that you can directly substitute from here and you will write over here. If you do it at the last page, from the last page to this page where you are writing your answer, probably you have saw there L power minus 3 and while writing you have written L power 3. So please don't do that. My video is showing all these things, not only the topic clarification but this also. Whenever you are doing this particular, and definitely this kind of a question will be there in your exam. Whenever you are doing, do the rough work in front of your answers only, so that you can easily substitute the value as what I am doing. So you can see, you can adopt the habit. So this is L power minus 3, this is M power 1, T power 0, whole power, density power is given as B. Earlier I was doing the power with X, Y, Z, I changed the power today ABC. Now Young's modulus having a dimension L power minus 1, M power 1, T power minus 2, whole power C. I hope this is all clear. Now here the next step, this is L power 0, M power 0, T power 1 is equal to K. This is L power 1 into A, M power 0 into A 0, T power 0 into A 0. Now next step, this is L power minus 3 into B, that is minus 3B, M power 1 into B is M power B and T power 0. Now next step. Now in the next step, my dear, this is L power minus 1 into C, L power minus C, M power C and T power minus 2C. Now next step, this is L power 0, M power 0, T power 1 is equal to K. This is L power, here it is A, here it is minus 3B and here it is minus C. So this is A minus 3B minus C. It should not be any mistake, my dear. So please practice this. Please practice a lot of this, because error sums, numericals, parallax method, distance finding numerical you can do. They are one simple method. But here this powers is keep on changing, and if you substitute wrong power, your entire effort is wrong. So this is A power minus 3B minus C. I have written M power 0, M power B and M power C. So this will be B plus C, because here it is 0, B plus C, and T power 0, 0 and last it is minus 2C. I hope, my dear, this is clear, and I will put this as equation number 3. And now, my dear, I will say here on comparing. You can see I will compare the power of L with the power of L, that is right power of L will compare with the left hand side power of L. The right hand side power of M, that is B plus C, will compare with the left hand side power of M, that is 0. And the right side of T power will be compared with the left hand side T power, that is minus 2C will compare with 1. So here I am giving the order comparing powers of both the side. So what I will get, my dear, first equation A minus 3B minus C is equal to, here L ke power mein is 0, this is equation number 4. Equation number 5, B plus C is equal to, here M power is B plus C and here M power is 0, that is 0. And T power minus 2C, so here I will write minus 2C is equal to, you can see here the T power is 1. So minus 2C is 1. This is my fifth equation. But this will give me, therefore my dear, C is equal to minus 1 by 2. I will put this as equation number 6. I got the value of C. Now my dear, as soon as I substitute C in 5, this sixth equation in 5, I am sure you know this much, this all algebra, B you can calculate. So here I will order here substituting equation 6 in 5. Now what is 5, my dear? B plus C is equal to 0. So since C is equal to minus half, you can see, therefore B minus half, in place of C I have written minus half, is equal to 0. So now you tell me what is B? B is equal to plus half. Equation number 7. I got B is equal to plus half, C is equal to minus half. So nice. So now my dear, I will order here substituting 6 and 7 in 4, sorry. 6 and 7 in 4. What is equation number 4, my dear? A minus 3B minus C is equal to 0. So this is A minus 3. And what is the B value? 1 by 2. Yes. Minus, here it is minus, and what is C value? Minus 1 by 2 is equal to 0. You can see, my dear, please don't do any mistake, right? It is fully algebraic. So this is A minus 3 by 2 plus minus and minus become plus 1 by 2 is equal to 0. I hope it is clear, my dear. Am I clear? If you are problem with this kind of equations, don't worry. Do one thing. Don't solve here. अगर आपको लगता है सर यहाँ मैं सॉल्व नहीं, माइनस का प्रॉब्लम हो जाता है, प्लस होना चाहिए था, माइनस होना चाहिए था, डोंट वरी. Do one thing, my dear. I can think you can write this as here I am writing A is equal to, take everything on that side, keep A alone here. Because, my dear, I know your maths is good, okay, fine, you can do, like, if you can do it. I am doing for an average student or below average student. If, my dear, you are finding there is a minus here is a plus, it make a confusion. Don't do anything like this. Take this thing on that side, that is here it is 0. So minus 3 by 2 will come on this side, become plus, and half will become minus. And A will be alone. So here the answer will be A is equal to 3 by 2. I have taken minus 3 by 2 on this side, become 3 by 2, and plus 1 by 2 become minus 1 by 2. Plus 1 by 2 on that side become minus 1 by 2. So now, my dear, I think you can solve. This is your 3 minus 1, and LCM is common, that is 2. And here it is 3 minus 1. Answer is 2 by 2. Answer is 1. So I think you got the answer. Therefore, A is equal to 1. That is equation number 8. A is equal to 1. That is your equation number 8. So you got 6, you got 7, you got 8. 8 A1, B is half, and C is minus half. Now, my dear, I think I will rub this and I will tell you the next step. Okay, so now the next step. So what is the next step, my dear? So here I will write okay. So here I will write, my dear, substituting 6, 7 and 8 in 1. What will happen in 1? So 1 is what? T directly proportional to or inversely proportional to. I don't know right now. After substitution I will come to know. Okay. So T proportional to, I will say, L power A, right, D power B, and Y Young's modulus power C. So T directly proportional to L power A. L power A, that is 1. So L is directly proportional to length. Directly proportional to length because power is positive. Super. Next, D power B. So D power B, B is 1 by 2. And Young's modulus minus 1 by 2. So now, sir, this can be written as T directly proportional to L power 1. No issue, 1 नहीं भी लिखा तो चलता है. But D power 1 by 2 can be written as root D. I have done so many sums into 1 upon, this will be written as 1 upon. Whenever there is a minus, it will be 1 upon because it will be inverse. This will be 1 upon y power half. First I have written this. Y power minus half can be written as 1 upon y power half. Now this will be t proportional to L. This is under root d into 1 upon y power half. जैसे d power half root d हुआ था तो y power half become root y. So now my dear, this will be t proportional to L under root. I have taken both root because d is also in root and y is also in root. So I have taken common root. In numerator it is d and in denominator it is y. Now my dear, from here I got 3 conclusion. What are 3 conclusion, my dear? What are the 3 conclusion I can do? First, t directly proportional to length. T directly proportional to length of prong. Sometimes we ask the question, line length बढ़ा तो time period क्या होगा? Sir, वो भी बढ़ेगा because directly proportional. So look at the best way of this question. और एक क्वेश्चन पूछ सकता है, लेंथ बढ़ा तो टाइम पीरियड ऑफ प्रॉन्ग का क्या होगा? सर, वाइब्रेशन ऑफ टाइम पीरियड विल इंक्रीज. सेकेंड, टाइम पीरियड इज डायरेक्टली प्रोपोर्शनल टू स्क्वायर रूट ऑफ डेंसिटी. डायरेक्टली प्रोपोर्शनल टू स्क्वायर रूट ऑफ डेंसिटी. आमने सामने है बट स्क्वायर रूट में. थर्ड, टाइम पीरियड इज इनवर्सली प्रोपोर्शनल टू, इनवर्सली, न्यूमरेटर डिनोमिनेटर कंसेप्ट, इनवर्सली प्रोपोर्शनल टू यंग्स मॉड्यूलस. I hope, my dear, this is the conclusion. Very good. And the last step, मेरे बच्चों, therefore t is equal to, the proportionality sign is removed by equal to k constant L under root d divided by y, where k is constant. Here is the answer over. I hope you all understood this sum. Here is the answer. This is the answer for this question, and these are the 3 conclusions I have drawn after doing the question. I hope you all understood this problem. My dear, thank you very much from my side. I am uploading second video on some more numerical. Second video also you please observe. Thank you very much and Jai Hind you all.